Okay, here we are in 10.4 or 5.4 in the book. Properties of logarithmic functions. You're going to use properties of logarithms to simplify and solve problems. So the product rule. For any positive number m and n and any logarithmic base a, log of base a m n is equal to log base a of m plus log base a of n. Here's the deal on this. Remember, logarithms are exponents, so they follow the exponent rules. If your base is the same and you're multiplying, you can add your exponents in the end. So on this one here, it says log base 4 of 64.4 would be, or 64 times 4 would be log base 4 of 64 plus log base 4 of 4. Now this is really all they're asking you to do, but we can prove this idea on just using the math. We know 4 to the third power is 64, that's 3, and log base 4 of 4 is 1. 4 to the first power gives me 4. So 3 plus 1 is 4, and 4 to the fourth power is 256. And if I took 64 times 4, I would get 256. So we're not going to go through the math because that's not what they're asking you to do. They will later, but not right now. Same with natural logs. Natural log of A, so this is being multiplied, plus natural log of B. And that's it. We don't have anything more to do on those. Okay, next one is the power rule. For any positive numbers m and any logarithmic base a and any real number p, log base a of m to the p power is the same as p times log base a of m. Go back to knowledge that you know. A power raised to a power, you multiply. And the log base a of m, that whole thing, is just a power. So this one here, again, all you're doing is taking your exponent and moving forward. So this would be 5 natural log of y. This one here is negative 8, bringing forward, log base b of q, negative 8 in front. And this is really natural log of a to the 1/2 power, and you bring the 1/2 power forward, and you have 1/2 natural log of a. Okay, now the quotient rule. You're dividing bases with exponents, you can subtract them. For any positive number m and n and any logarithmic base a, log base a of m over n is log base a of m minus log base a of n. So this one will be written as log base a of 76 minus log base a of 13. Now this one here we can prove in the calculator, because you can put this in the calculator, just use base 10, put this in the calculator, and then put this in the calculator, don't get the parentheses, and you will get the same values. Okay, and then this one, natural log of a minus the natural log of b. These are things that you have to familiarize yourself. I would highly suggest these ones. Any of these properties is get out a note card and write them out. That way later on you have a quick card to just turn to and look at all of these. So I'm going to put that high suggestion out there that any past sections in this chapter, next sections in the chapter, something like this comes up, write it out there. These are properties you have to know. Okay, so this one here, I am going to show why this one is such. The logarithmic of a base to a power for any base a and any real number x, log base a of a to the x is just simply x. Well, this one is an easy one because we can use the power rule. So this one here, according to that statement, the answer is going to be 2713. Well, let's show you why. Power rule tells me I can bring the power forward. So this is 2713 log base t of t. This guy here is equal to 1. How do we know? Because I'm asking you t to what power will give me t, the first power. So our answer is just 2713. So the same thing here. I bring the power forward. So we're doing it the long way. But I'm letting you know the answer here is just going to be radical 3. It is radical 3 log base q of q. But this guy here is equal to 1. So it's just square root of 3. Okay. This is the easy one to do. You're just going, oh, okay, the base and the other is the same, so it's just the power. This one is not as easy. So we have for any base a and any real number x, a to the log exponent will give you just that product that's in there. So we have to add y to it. So according to this statement here, the answer is 4x minus 3. But what we're going to do is we're going to change these to logarithms. So I have log base 5 of y will equal log base 5 of 4x minus 3. Now this is a property you used, I believe in the last section we learned it, is how to change exponential to logarithm. It's your base, this is your base, and this is your exponent. So we separate them. Log base 5 of y, this guy here, equals the exponent. Whenever you have logs on, you have one log on each side, you can cancel them out because that's a function. Kind of like doing the square root equaling the square root. You can take them both off. And you're left with y equals 4x minus 3, which we already claimed to be the answer. So this one here, same idea, is that if I did this again over here, the answer is going to be x to the third, but we're going to get the natural log of y equals the natural log of x cubed. Just changing it from exponential to logarithm. The logs are exactly the same on each side, so we can separate them out. So we get y equals x cubed. And there's our answer. So you find this, the base is the same as the base. Get rid of the e, get rid of both the bases and the log, and whatever's left is your answer. That's the same over here. The base is equal to the base with an exponent on it. Drop them out. Okay, and then this is just getting you using some of those properties. Log base a of 14. They're giving you log base a of 2 is this value, log base a of 7 is this value, and log base a of 11 is this value. Find each of the following if possible. So this one here, well, we don't have a 14 up there, but we do know 14 is 2 times 7. And we have 2, and we have 7. So we can use the product rule. Log base a of 2 plus log base a of 7. 2 is 0.301 plus log base a of 7, 0.845. And then we add these two up. Change my pages. Add these two up and we get 1.146. Okay, the next one, 1 divided by 7, so we can use the quotient rule. So this is log base a of 1 minus log base a of 7. We don't have 1 up here, but we'll talk about that in a minute, but we do have 7. But anytime you get log of 1, it's always going to be 0. So this is 0 minus log of 7, 0.845. So this is negative 0.845. Some people won't bring this down and they'll lose their negative with it, so be very careful. And then log base a of 9, well, this is 1 times 9, or 3 times 3. But there, we can't use 2 and 7 to get there. Please don't go, oh, this is 7 plus 2. Yes, you're right. 7 plus 2 is 9. But log of 7 plus log of 2 is not 9. So this one is not possible. Only because we don't have the values to use. Okay, this one should give you plenty to do. 1 through 21, every other odd, and then jump to 53 through 67, odd. And then on the next video, we'll finish up this section. Good luck.